Okay, so now we know how to navigate around terminal, connect to discovery, create an input file, create a bash file. We've set up our bash profile, and so now we are on to interpreting our results. So after the job will run, we'll have these 4 files at the very least. An output file, an error file, a log file, and a checkpoint file. As I mentioned before, the output file and the error file are more computer output files. They will give you information like if the program tried to reference a file that didn't exist, or if like a node crashed in the middle of the job, it'll be in this one. But usually all the relevant information will be in the .log, which will contain everything from the successful output, or maybe it'll have clues of why your job failed. And then finally, the .check you can't open through terminal, but you can open through Gauss view, and it'll have a lot more information, but just wanted to include that there. So here I have some example files I can show you. Obviously the output files will be completely dependent on the jobs that you're running, but let's look at this, which is an optimization job. Okay, so if we look at the job itself, let's look at op.com. So this is the job that I was trying to run. Now if we go to the .log, there's obviously a lot of stuff in here, especially if you're not used to looking at these log files yet. It's a little bit daunting. So really, there's only like a few things that you need to find usually, like this SCF done. So this is the electronic single point energy, which you can also find in Gauss view. If you look at the results, note that this might not be your actual output energy. If you're adding a frequency analysis on top of it, there are optional corrections to this energy that include the vibrational energy. And then let's go down to the bottom of this, so capital G, and this is what we like to see, normal termination. So that means the job finished and everything went as planned. If we want an example of something that didn't work, so this is a CP command, by the way. This will copy files and you can give it a different name, badopt.com. So let's open up that. Now let's say you were in a rush and you actually put in the second T right there. Make sure to update this. Okay, so I'm just gonna skip some steps right here. So we run this, and now we're gonna wait for a return, which probably won't be too good. This is pretty much like, yeah, so it has a problem with this. It has a little apostrophe right there because it has a syntax error right there. See, a syntax error is detected on the input line. If you look at the output file, that's not very useful. Yeah, segmentation violation. That's kind of like the all-encompassing error thing that will usually come out of the error file. This file is very not often useful to people who are not computer savvy, but it's good to have just in case. There's some other ways that it can go wrong. Like let's say perfect spelling brings it like, oh, I want it to be a doublet, and then so you go in and you submit the job. You want it to be a doublet. This is it's not physically possible for this molecule to be a doublet with a negative charge. So when it tries to calculate this, it's going to be very confused because it doesn't know how to orient the electrons. So yeah, it's going to say down here, the combination of multiplicity 2 and 30 electrons is impossible. Error termination. Notice that these kind of dumb errors, dumb quotation mark errors, usually occur really quickly. Like they will pick up on it like within the first 10 seconds. So like once your job's been running for about 30 seconds, then you will know that everything's good, or things should be good. So there's like about a million ways that a job can mess up in Gaussian. Way too much that you can cover in a single video or just to have anywhere. So if something goes wrong, just like looking through your log file, looking through your output file, looking through your error file, try to find clues to what happened and really just Google it. That's usually what I do, and it works like 90% of the time. And then of course, you submitted it, it's a normal job as before, so you can always go through discovery, go into the folder and look at either the .log or the .check, just as you did in your old quantum class or your old PChem class, and you can look at the output of the file in a more user-friendly way.